Good morning to all. I am Nikitha, Assistant Professor, Department of Chemistry, KSR College of Arts and Science for Women. Now we are going to discuss about nanotechnology. Richard Feynman laid foundation step of nanotechnology in his lecture, and there is plenty of room at the bottom. Dwarf, it's a green word. It means nano. Definition of nanotechnology: the manipulation of matter with at least one dimensional size between 1 to 100 nanometer. A nanometer is a unit of length in the metric system equal to 1 billionth of meter, that is 10 power minus 9. Technology is the making, usage and knowledge of tools, machines and techniques in order to solve a problem or perform a specific function. Nanoparticles characterization is necessary to establish understanding and control of nanoparticle synthesis and application. Characterization is done by using a variety of different techniques like scanning tunneling microscope, STEM, atomic force microscope, electron microscope, dynamic light scattering, X-ray photoelectron spectroscopy, powder X-ray diffraction, Fourier transform, infrared spectroscopy, ultraviolet visible spectroscopy, dual polarization, interferometry, and nuclear magnetic resonance. Next one is synthesis of nanomaterial. It is done by using two methods. First one is bottom up method, second one is top down method. First one, bottom up approach. In the bottom up approach, molecular components arrange themselves into more complex assemblies, atom by atom, molecule by molecule, cluster by cluster from the bottom. For an example, growth of crystal, molecular components arrange themselves into some useful conformational using the concept of molecular self-assembly. For example, synthesis of nanoparticles by colloid dispersion method. Second one is top-down approach. In this approach, nanoscale devices are created by using larger, externally controlled devices to direct their assembly. The top-down approach often uses the traditional workshop or microfabrication method, in which externally controlled tools are used to cut, mill and shape material into the desired shape and order. Attration and milling for making nanoparticles are typical top-down process. Hybrid approach. Both the techniques, that means bottom up and top downs, are employed. Lithography is an example in which the growth of the thin film is a bottom up method, whereas etching is a top down method. Nanoparticles are synthesized using techniques such as ultraviolet irradiation, aerosol technologies, lithography and laser ablation, ultrasonic field and photochemical reduction techniques. Disadvantage: expensive and involved use of hazardous chemicals. Green synthesis: make use of biological system. Disadvantage: low monodispersity, low protection rates and high protection cost. Next one, structure of nanomaterials. It is classified into four types. First one, zero-dimensional nanostructure. Second one dimensional nanostructure. Two-dimensional nanostructure, and the last one is three-dimensional nanostructure. One good example for zero-dimensional nanostructure is nanoparticles. One-dimensional nanostructures are nanowires, nanorods, nanocables and nanotubes. Two-dimensional nanostructure is thin film. Three-dimensional nanostructure is colloid bearing complex shapes. These are some examples for nanomaterials: fluorine, carbon nanotube, graphene, carbon dots, nanodiamonds. Carbon nanotube. It is called CNT, tubular form of carbon, diameter as small as 1 nanometer, length few nanometer to microns. Configuration is similar to 2D graphene sheet rolled in a tube. Two types of carbon nanotubes are single wall nanotube and multi-wall nanotube. Single wall nanotube made up of single rolled graphene layer, difficult to synthesis in pure, defect free form. It accumulates leads in the body, hence used for biological purpose. Multi-wall nanotube made of bunch of graphene layer rolled together. Bulk synthesis is easy, high purity is attained. It accumulates more in the body. Application of carbon nanotubes. It helps in creating the lightweight spacecraft, easily penetrate membranes such as cell wall, help in cancer detection and treatment. It helps in developing sensor that can detect chemical vapor. Fabrication of gene chips can be done, used for environmental monitoring and pathogen detection. Some limitations: difficult to produce in bulk, maintaining homogeneity and purity. It's scarcely soluble in water, can be overcome by frictionalization. Next one, quantum dots. It is also called nanorod. A crystalline nanoparticles made of semiconductor material, small enough to show quantum mechanical properties. Dimensional range from 1 to 100 nanometer. Electronic properties are intermediary of bulk semiconductor and discrete molecules. They are closely related to their shapes and size. The size is inversely proportional to the band gap. Made from range of material: zinc sulfide, lead sulfide, cadmium selenide and indium phosphate. Can be toxic while using in human body, therefore coated with a protective polymer. Next one, nanowire. It is also called quantum wires. Extremely thin wire. Thickness of diameter is equal or less than 10 power minus 9 meter. Aspect range equal to or greater than 1000. Application of nanowires. Development of microprocessor, prototype sensor and nanorobots. Used for biosensing purpose, nanowire based devices are ultra sensitive and thus can detect wide range of biological and chemical species from DNA to drug molecule and virus and pH. Can detect the presence of altered gene associated with cancer and even determine the exact location of the mutation. Next one, nanofiber. Produced from a variety of polymer like nylon, polystyrene, polyacrylonitrile, polycarbonate and water-soluble polymers. Generally not used as a single fiber, thus layered as a sheet or mat. Properties of nanofibers: low density, large surface area to mass, high pore volume, small pore size, superior mechanical properties and possibility to incorporate different additives. Application of nanofibers: peptide nanofibers associate to form nanofiber scaffold with well ordered nanoporous, ideal material for 3D cell culture of artificial organs or tissues, controlled cell differentiation, generative medicines, wound healing, and slow drug delivery application. Used to make sensor to detect chemical agent, filter for air, water, beverage, oil and fuel purification, lightweight clothing, better efficiency, batteries and food packaging. Some example some example of application of nanotechnologies are energy, medicine, drug, nano devices, optical engineering, bioengineering, nano fabrics and etc. Nano biosystem, medical and health application, enhanced biological imaging for medical diagnostics, early diagnosis of atherosclerosis or build up of plaque in arthritis, multifunctional therapeutics and etc. Agricultural applications are nanotechnology enable delivery of agricultural chemicals, field sensing system to monitor the environmental stresses and crop condition. Nanotechnology enable the study of plant disease mechanism, improving plant traced against environment stresses and diseases. Electronic and information technology application, nanoscale transistor, magnetic random access memory enabled by nanometer scale magnetic tunneling junctions. Display for electronic items incorporate nanostructured polymer film known as organic light emitting diodes. Flash memory chips for iPod nanos. Ultrasense, ultra responsive hearing aids. That's all about today's topic. Thank you.